Welcome to Morrow Teaches Online with your host, Mr. Morrow. Yes, thank you. I know I'm slightly going insane. Thank you. It's good to be back. Okay, so today we are almost crossing subject areas to science. Yes, we're doing how do we perform operations with scientific notation. Guess when we use it a lot? That's right, in science class. It helps to describe really big things or really small things. So, before we do that, let's look at the homework. So, extraneous, let's check it. Again, if the question's asking are any extraneous, then you should talk about extraneous. But if it's just saying solve the question, just solve it and don't talk about extraneous. So, for number one, when you try out one, it worked. When you tried out two, it also worked. So there were no extra. Wait, hold on. Let me check that. I do not like how these were written. Let's try that again. So, when you do that, I would never do it this way. The square root of 1 is 1, which is what we wanted. And when you do it, then the square root of 4 is 2. Honestly, I don't like any way that this was done. Okay, it should always say 2 equals 2. That's good. 1 equals 1. That's also good. Whoops. Okay. The next one, again, I don't like how it was written. So, it should be the square root of 3 plus 6 is the square root of 9. The square root of 9 is 3. Does 3 equal 3? Yes, it is. So that worked. Okay, but when you do this, square root of that, square root of 4 is 2. Does 2 equal negative 2? No. So the negative 2 was extraneous. That's the only time you should ever write it's extraneous. If we're asking, are there any extraneous solutions? For number 3, though, it says solve it. So don't talk about it. So what are we missing from all these that makes it really bad? Yes, it said check your solutions. Man, does this homework key not do what it's supposed to do. So when you do the check, here we go. So we got to try out the answer. 3, does that equal the square root of 2 times 71 plus 2 minus 9 on the outside? 2 times 71 is 142. 142 plus 2 is 144. The square root of 144 is 12. Is 12 minus 9 3? Hey, 3 equals 3, so 71 did work. For number 4, when you solve it, move the 11 first. You get 12. Divide by 3. You get 4. To get rid of a square root, square both sides. Solve that two-step equation. You could have written that. Personally, I hate fractions, so I would have written this. 5.5. Take my word for it. If you plugged it in, it would have worked. Okay, again, we don't have checks for you. I don't know why. So, minus the 5. Now, you cannot say, hey, there's no answer, because if you notice, there's still things outside. And notice when you now divide by negative 2 outside, it becomes positive. So this will work. So be careful, because a lot of students really like to say, oh, I see a negative, it can't work. No, do everything outside first, because it might change it to a positive, which is what it did. Then square both sides, solve it, whoops, minus the 2, then divide by 7. And there's your answer. If you checked it, it would have worked. For this one, again, you're going to have to go straight into squaring first. Move everything to one side. Do double bubble. Solve each bubble. You get negative 7 and 2. You know negative 7 is not going to work. Technically, this is a wrong answer for number 6. They did exactly what I said don't do. Don't tell me negative 7 is extraneous. Tell me 2 is the answer. That's the answer. Because when you do the checks, which they should have done, when you check negative 7, it does not work because you can't square root and get negative 7. But 2 will work. Okay, number 7 and 8. To get rid of a cube root, just cube it. You get 27. Again, to get rid of cube root, just cube it. And you get 8w equals 1,000. Divide by 8. W equals 125. Okay, go straight into cubing. Okay, and then solve it. You get that. Go straight into cubing and solve that. And it works. Okay, so scientific notation is a shorthand way of writing very large or very small numbers. The number must be a decimal between 1 and 10. Very small numbers have negative exponents. So, a time when you would use this, if we're talking about how large the mass of planets are, you don't want to write that many zeros. So, the mass of the sun, you ready for this? It's 1989. Here we go. That's how, oh, hold on. Kilograms. That's how big the sun is. So let's see what that is. I'm not even going to pronounce this number. I don't even know if I could pronounce this number. Yeah, that's a pretty big sun. So that would be really, really, really annoying if I had to write that every single time. So you're going to learn how to do this, but a much faster way is just to write that. Wasn't that a lot easier? So scientific notation is to write really, really, really large numbers or really, 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 really small numbers. Like if I was talking about how wide a molecule is or how wide an atom is, that would be 0.000000000 and so on. So there has to be a faster way to write it. So again, we're not solving really anything today. I mean, we are going to do some multiplying and dividing, but today's more focused on how to rewrite the answers in a smaller shorthand version. So here are the rules to writing scientific notation. First rule is put a decimal somewhere in the number where you'll get a number between 1 and 10. Do you see if I put a decimal right there, I make the number 2.4? 2.4 is between 1 and 10. And again, some people use money just to help them out with tricks. So if I said, hey, what's between $1 and $10? You would say, oh, $2.40. Yes. Okay, it will always go after the first non-zero number. So not after the first number, because sometimes the first number is a 0. It's after the first non-zero number. So only thing you write now is 2.4. The way this was described to me a long time ago, picture like it's on a seesaw or a scale. If I tilt it to one side, think of the zeros as like wheels. The wheels will roll off, so what's left? Just like the 2 and the 4, or in B, the 8 and the 5 would stay. Okay? So you pick a number between 1 and 10, so 2.4. Now you write times 10. You will always write times 10. And now all you got to do is just swoop from the decimal till the very, very end. 1, 2, 3, 4, 5, 6, 7. And there's your answer. 2.4 times 10 to the 7th. Okay? So for the next one, again, put a decimal somewhere where it will make a number between 1 and 10. So 8.5 is between 1 and 10. Okay, you write times 10, and now swoop. 1, 2, 3, 4, 5, 6. Again, the reason why kids mess up this topic is because they think the exponent represents how many zeros there are, and that's wrong. It's how many swoops it takes to get to the end. Okay, but here's what's nice. On your calculator, if you go to mode, look at the first line. You see how it's blinking on normal? Look right to the right of that. You see how it says psi? What do you think that stands for? Scientific notation. So if you go over and press enter, and then press second mode, which is quit, any number you type in now will write it in scientific notation. Now it writes it in a weird way. Okay, you ready? Instead of writing times 10, for whatever reason, your calculator writes E. So if you ever see E, which you've probably seen before on the table, when we were doing exponential functions, you probably saw E a few times. It just meant times 10. That was scientific notation. So I read this as 8.5 times 10 to the 6th. So the calculator could do all the work for you. The only thing is when you're done with scientific notation, you need to remember to switch it back to normal, or else all your answers will be scientific notation. For example, 1 plus 1, it's 2 times 10 to the 0th. Yeah, so make sure you switch it back to normal. Okay, but yeah, the calculator can do most of the work, and personally, I'm going to do most of the work. Now, for 1C, remember how I told you the zeros roll off? Yeah, but look at this zero. You see how it's stuck between the 3 and the 6? So that's not going to go anywhere. So I don't want you to think you always get rid of all the zeros. You only get rid of the zeros that are on the ends. So here we go. Put a decimal. $3.06 is between $1 and $10. So 3.06, and now swoop. 1, 2, 3, 4, 5. So times 10 to the 5th. And there's your answer. The next one. Notice how now this is a small number. Do you agree if it's 0.00000? That's a small number. The same rules apply, but there's already a decimal. We're going to be putting in a new decimal now. So we're going to put the new decimal. Remember, it goes after the first non-zero. The first non-zero was a 3. So 3.72, is that a number between 1 and 10? Yes. Times 10, but now look how this one works. We need to swoop from the new one back to the old. 1, 2, 3, 4, 5, 6. But if you swoop to the left, it will be a negative exponent. Okay, so when it's a very, very small number, it's a negative exponent. When it's a large number, it's a positive exponent. Okay, so again, pick a new decimal. So 2.1. And now swoop. 1, 2, 3, 4. Times 10, but since it's a small number and we swoop to the left, it's negative 4. But again, your calculator can do all the work. So like for the next one, the only reason, again, why kids mess this up is because they count the amount of zeros wrong. There's 1, 2, 3, 4, 5, 6. So if you're lazy, you can just type it in your calculator. So 0.1, 2, 3, 4, 5, 6, and I believe it's at 11. And it will tell you it is 1.1 times 10 to the negative 7. So honestly, I would just say let the calculator do all the work. Again, it depends on what your teacher wants. For my students, go for it. Use the calculator. What did I say? Negative 7? Yes. All right. So for the next one, it would be you would never really use scientific notation for the next one because, again, it's to describe really, really, really big numbers or really, really small numbers, and that number is neither. So the only thing you have to do is 45.6 is not between 1 and 10. But here's why this is dumb. So there's your new decimal. So 4.5, you actually have to write all the numbers because do you see how there's a 1 at the end, which means that 0 gets stuck. It can't roll anywhere, so it stays there. That's why this is kind of dumb. It's supposed to save you time, and if you're just writing the same amount of numbers, how is that saving you time? So it's a big number, so it's going to be a positive exponent. So let's see how many swoops it took. 1. So it took 1 swoop. So there it is. That would be really, really dumb to use scientific notation for. There's the new decimal, so it's 5.017, and the rest of the zeros roll off. And here we go. 1, 2. So times 10 squared. Okay? Easy enough? Not so bad. Okay. So now it says write them in standard form. So scientific notation is what? Writing it with times 10. Standard form just means write it like a normal number. So here's all you have to do. 5.7, rewrite that, and then the exponent tells you how many swoops. 1, 2, 3, 4. Fill the empties with zeros, and then just rewrite it so it looks pretty. Again, it doesn't mean how many zeros there are. It tells you how many swoops. 2.24, whoops. Yeah, 2.24, and now 6 swoops. 1, no. 1, 2, 3, 4, 5, 6. Fill the empties with zeros and rewrite it and make it look pretty. Pretty. Again, your calculator can do this. Now, it doesn't work all the time because sometimes if the number's so big or so small, it has no choice but to write the answer still in scientific notation. But if you want, just type in the question. Now, you got to switch back, go to mode. You got to switch back to normal mode to do it. So if we type the question, and the question was 1.06 times 10 to the 9th. Come on. 1.06 times 10 to the 9th. Just copy that number. I mean, if you want to type it in, go right ahead. So it has 7 zeros at the end. So just make sure. Again, the reason why kids get this wrong is because you didn't write down enough zeros. 1, 1, 0, 6, and then 1, 2, 3, 4, 5, 6, 7. Put in your commas, and it's beautiful. Okay, 3.9 times 10 to the negative fifth. That tells you you're going to be swooping to the left. So rewrite the number, but now you're going to swoop 5 to the left. 1, 2, 3, 4, 5. And now put your new decimal there. Fill the empties with zeros. Rewrite it so it looks pretty. Okay, 1.82, swoop it 7 times to the left. 1, 2, 3, 4, 5, 6, 7. I did not leave myself a lot of room. Okay, so 1, 2, 3, 4, 5, 6, 1, 8, 2. So this is not a hard topic by any means, at least this part. 9.004, swoop it 3 times to the left. 1, 2, 3. 0.009004. Okay, this one's a positive exponent, so 12745.72. And this one says 41234. 49120.6. Okay, not that hard. Okay, now with multiplying and dividing. Again, personally, I like using a calculator. I'm going to teach you how to do it by hand, though, first. Again, it depends on your teacher. I would ask your teacher what they want. Morrow kids, use a calculator. Why not? For other students watching this video, you ask your teacher first, because some teachers like it different. And I don't want you getting penalized on a test or a quiz. So multiply the coefficients, add the exponents. If you're like, where have I heard that before? Remember MK when we did exponents, multiply the coefficients, add the exponents? Well, that's what you're doing. So, I mean, they're not really coefficients because they're not variables, but here we go. 4 times 2.21. So you're going to type that in first. 4 times 2.21. You get 8.84. 8.84 times 10 to the, and now just add the exponents, and you get 8. And there's your answer. Now, before you call that a final answer, you should always check, is this number between 1 and 10? Yes, so you did it right. If it's not between 1 and 10, that's when then kids mess it up, and that's why I like the calculator personally. But we're not at the moment. So 3.03 times 1.03. Here we go. 3.03 times 1 point, and I already forgot. 1.03, yeah. Okay. 1.03. So 3.1209. So let's write that. 3.1209. I did write that correctly, right? I have such a terrible memory. Times 10 to the, add the exponents, 9. And again, make sure the number is between 1 and 10. It is, so you did it right. The next page. 7.3 times 1.2. Here we go. 7.3 times 1.2. 8.76. 8.76 times 10 to the, add the exponents, 10th is the number between 1 and 10, then we did it right. And again, you don't need to underline it. Now, this is where we're going to have problems. 9 times 4.71. So when you do that on your calculator, 9 times 4.71, you get 42.39. And again, I forget which teachers want you, but sometimes you actually do need to show the work. Again, my students, I don't care. 42.39, 42.39. But something's going to be a problem soon. 42.39 times 10 to the 4 plus negative 2 is 2. Now, if you circle that, it's wrong. In order for it to be in scientific notation, this number needs to be between 1 and 10. Is 42.39 between 1 and 10? No. So you got to swoop the decimal. So when you swoop the decimal to where it needs to go, that's going to affect the exponent. So I want you to memorize this. Memorize LERD. It stands for, if you go to the left, move the exponent up. If you go to the right, move the exponent down. So which direction did I have to move? I had to move left. That means raise the exponent by 1. So your final answer is 4.239 times 10 cubed. The reason why I like the calculator is the calculator will fix that problem on its own. So if you go to mode, switch back to scientific, and now type the question. Again, it was, I can't memorize it, 9 times 10 to the 4th, 9 times 10 to the 4th, and what did I not do? I forgot to put it in parentheses. 9 times 10 to the 4th, and now you got to actually get down from the exponent. And now type the other part. 4.71 times 10 to the negative 2. 4.71 times 10 to the negative 2. Now, if it's in scientific mode, it will do it for you. 4.239 times 10 cubed. That's why I like the calculator better. And there's your answer. Okay, the next one. 6.06 times 4.01. When you do that, you get 24.3006. Add the exponents, you get 10 to the 8th. But the problem is, when you write this answer down, SpaghettiOs. Do they even have that commercial anymore? Is that number between 1 and 10? 24? No. So we got to move it to the left. When you move it to the left, this goes up 1. So the answer is 2.43006 times 10 to the 9th. Honestly, I would just use your calculator if your teacher allows it. 9.3 times 5. When you do that, 9.3 times 5, you get 46.5. That's going to cause us problems. So 46.5 times 10 to the negative 7 times 3 is negative 4. Now, we got to move this to the left. When you move it to the left, that goes up. So 4.65 times 10 to now the negative 3. So how are we doing on this? Good? Sweet. Okay, division, guess what? The same rules apply. Remember, divide the coefficients, subtract the exponents. Okay, so again, you're going to divide it. 3.6 divided by 1.2 is 3, but then you're going to subtract the exponent. So the answer is 3 times 10 cubed. Same rules apply, though. Okay, 9.04 divided by 2. When you do that, you get 4.52. When you divide, subtract the exponents, you get 5. 4.52 times 10 to the 5th. Is the number between 1 and 10? Yes? Then that's your answer. The next one, 1.221 divided by 5.5. We're going to have problems. 1.221 divided by 5.5. You get 0.222 and then subtract the exponents. So remember, when you subtract the exponent, 6 minus a negative 3 is a positive 9. So now we have this. 10 to the 9th. What's wrong with this? Is 0.222 in between 1 and 10? No. So we got to move the decimal to the right. So remember what I said. It's LERD. If you go left, go up with the exponent. If you go right, go down. So since we move to the right, the exponent goes down 1. So 2.22 times 10 to the 8th. And there's your answer. For the next one, I'm just going to use a calculator. So, okay, fire up the calculator. Again, am I in scientific mode? Yes, so I'm ready to do this. Just type in the question. 1.8 times 10 to the negative 4. Move down so the parentheses are down. Then the next one. Oops, nope, we're dividing now. So divide, parentheses, 1.2 times 10 to the negative 6. Nope, I need to do an exponent. To the negative 6. And here we go. 1.5, and remember, E means times 10. squared. 1.5 times 10 squared. Again, if you're one of my students, you don't need to show work. If you're not one of mine, ask your teacher. Okay, 8.5 divided by 2.5. When you do that, you get 3.4. That's good. When you divide, though, you subtract the exponents. 3 minus 6 is negative 3. So you get 3.4 times 10 to the negative cube. Okay, the next one, 1.18 divided by 4.3. We're going to get into problems again. 1.118 divided by 4.3. You get 0.26. So now we have 0.26 times 10. Negative 7 minus 4 is negative 11. But that number is not between 1 and 10. So move it to the right. If you move it to the right, then the exponent goes down 1. So remember, we're in the negatives, though. So 2.6 times 10 to the negative 12. Okay, 5.12 divided by 3.2. When you do that, you get 1.6. And you subtract 4 minus a negative 2 is positive 6. And this does work. And that number is between 1 and 10. Okay, is this the last question? Yes, it is. Let's do it. In 2010, the world population was about 6,860,000,000. The population of the United States was about 3 times 10 to the 8th. All right. About how many times larger is the world population than the population of the United States? So if you wanted to figure out how many times larger, that means we're going to have to divide so we know how many times more the world population is. Now, what's the problem? One's in standard form, one's in scientific notation. So which would you rather do? Why don't we turn the world population into scientific? So 6.86, and now let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got times 10 to the 9th. So 6.86 times 10 to the 9th divided by 3 times 10 to the 8th. So we do 6.86. We'll do this on the side. 6.86 divided by 3, or use your calculator. That looks terrible. Let me write that again. 6.86 divided by 3. And you get 2.28. You get 2.286 repeating. Ew. So why don't we round that to the nearest hundredth, since it says about how many times larger? So, I mean, about is such a relative term. We'll just say it's 2.29. Okay? And then when you divide, just subtract the exponents. So 2.29 times 10 to the first. You could just write that, or you could just say it's about 22.9, which is about 23 times larger than the population of the United States. Okay? We don't usually ask you questions like that, but yeah, about 23 times larger. Cool. So there it is, guys. It's been fun doing another lesson with you, and I look forward to doing another. Huzzah! Yay! Huzzah! Bye-bye.